G'day, Year 7. Welcome back to another week, a final week of online learning. Today we're starting a new topic. We're looking at something which is now called Pythagoras Theorem. Now you might ask, that's a funny name. Pythagoras was an ancient Greek mathematician. He was also a musician, a philosopher. He had a school of people who sort of studied under him, who were credited to all sorts of interesting things that they learnt about and discovered. And what Pythagoras' theorem is it measures the relationship between the sides of a right-angled triangle. So all the things we're going to be looking at in this topic have something to do with right-angled triangles. Now, a right-angled triangle is just a triangle that has a right angle in it, which we know is equal to 90 degrees. So one of the angles in the triangle is equal to 90 degrees, and then the other two angles are going to be less than 90 degrees. Now, Pythagoras came up with this rule, which we're going to talk about shortly, but this was actually known well before. The ancient Egyptians were shown that they understood this law, perhaps not in a formal sense, in writing it out as an equation like Pythagoras did, but they were able to construct buildings using techniques that use this law. So even though they might not have been able to write down the equations in the same way, they did understand the mathematics in a way that enabled them to build massive buildings. And so all of the sort of advancement that we've had in structure, in architecture, in engineering, comes from our increased understanding of mathematics. So this is sort of our first sort of break into that field. So I hope you find that interesting. Okay, so every right-angled triangle has two short sides and a longest side. Okay, and that longest side is always opposite the right angle in the triangle, and we call it the hypotenuse. Okay, it's a bit of a strange word. Again, it has Greek roots, so a lot of our understanding of mathematics comes from ancient Greece. But we have here our diagram. So we've got A and B, which are the two short sides. We've got a right angle in between them, and then across. Okay, you can see it's opposite, which means it's across from, looking across at. That right angle, you've got the hypotenuse side, which is the longest side of the triangle. Okay, and we've labeled the short sides A and B, and the hypotenuse we've labeled C. Now, Pythagoras discovered that the length and the short sides and the long side follow an equation. So if a squared plus b squared equals c squared, okay, then the triangle is right angled. Now, what is A, what is B, what is C? A and B are the short sides, okay? So if you square one of the short sides and then you add it to the square of another short side, then those two will add up to the square of the long side. And that will always work if you have a right angled in that triangle. Now, if those short sides squared and added together do not equal the square of the long side, then that is not a right-angled triangle, okay? It's still a triangle, it just doesn't have a right angle in it. So A and B are the short sides, C is the hypotenuse, our equation that we're going to be looking at a lot, and you will remember this because we're going to use it a lot, is A squared plus B squared equals C squared, okay? So here's an example of a question. We have to determine if each triangle is right angled using Pythagoras' theorem. Now, we don't know yet if they are. We have to show. So what we need to do is we need to identify what the short sides are, and we need to identify the long side. So we have 5, 12, and 13. The longest side is 13, so that's going to be our long side. And what we're going to do is we're going to say A squared plus B squared. Okay, those we're going to say are the short sides of the equation. Equals, so A is equal to 5. It doesn't matter which one is A or B in this instance. So 5 squared plus 12 squared. Okay, and then we're going to put that in our calculator. 5 squared plus 12 squared. And that gives us 169. Okay, and then c squared is going to be 13 squared. So we're going to put that in our calculator. 13 squared equals, and we get 169. So therefore, a squared plus b squared equals c squared. And the triangle is right angled. So the way we set out our working and show our logic is important. We first worked out what a squared plus b squared was, and we wrote that down, and we substituted the values of the short sides in for a and b. And we got our answer. Then we did a new equation, and we found out what c squared was equal. And we recognized that we got the same answer for the two. So therefore, we can say that those a squared plus b squared equals c squared, and it's going to be a right angled triangle because it follows Pythagoras' theorem. Okay, let's try this again. We've got 8, 9, and 12. So 12 is obviously the longest side. So a squared plus b squared is going to equal 8 squared plus 9 squared. And we're going to put that in our calculator. 8 squared plus 9 squared equals 145. Okay, and then c squared is going to be 12 squared. And we put that in, 12 squared, 12 squared equals, and we get 144. We can see we're really, really close. We're really close, but it's not the same. It has to be exactly the same. That's what Pythagoras' theorem says. Not almost, exactly the same. So therefore, a squared plus b squared does not equal c squared. So that's our symbol for not equals. So equal sign with a line through it. And we can say the triangle is not right angled. Now, because we're really close, it's probably going to be an angle very close to 90 degrees in the 80s or 90s somewhere, but not exactly 90. And that's what we're looking for. Okay, so hopefully you understand how to set out your working. When you do the questions today, make sure you set it out just like I've done it today. Don't try to shortcut the way you write it down. Set it out like this. Don't just write your answer. Show your working, because that's what you'll need to do later on. All right, good luck with the work today. I'll catch you later.